Hello students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for another session in basic concepts of chemistry. Let us see how to balance the redox reaction equation now. Actually, there are two methods to balance these reactions. They are the oxidation number method and the next one is the ion electron method. And in this video, we are going to discuss about the oxidation number method, okay? See, if you want to balance the redox reaction equations, we should follow certain steps, okay? So let me give the steps first and then I shall explain the examples, right? So these are the rules that has to be followed for balancing the redox reaction equations. Actually, there are 5 important steps. Step number 1 is identify atoms which undergo oxidation and reduction. Step number 2 is balance the atoms undergoing oxidation and reduction. Third one is we should balance the charges by cross multiplication. Fourth one is balance all the other atoms except oxygen and hydrogen. And the final one is balance the hydrogen and oxygen atoms. Okay. So actually in the first step, that is identifying the atoms which undergo the oxidation and reduction, how to find out which atom is undergoing oxidation and which is undergoing reduction? Actually it's very simple. First we should find out the oxidation number for all the atoms. Okay. Actually, the atoms undergoing oxidation and reduction will be seen both on reactant side as well as on the product side. If suppose the oxidation number of an atom is increasing, that means it is undergoing oxidation. That is, oxidation is taking place. If suppose oxidation number is increasing means it shows that that particular atom is undergoing oxidation. Okay, that is undergoing oxidation. If suppose the oxidation number is decreasing, that shows that that particular atom is undergoing reduction. Understood? Actually, in the second step, this step is very important. Balance the atoms undergoing oxidation and reduction. Actually, this is very important. Actually, we have found out which atom is undergoing oxidation and reduction in the first one, is it not? And now in the second step, we should balance those two atoms which are undergoing oxidation and reduction. Okay. So next one is balance the charges by cross multiplication. In step 3, we should balance the charges by cross multiplication. That you will understand when I do that. Okay. And the next we should balance all the atoms except hydrogen and oxygen. Okay. Leaving behind this high oxygen and hydrogen, we should balance all the other atoms present in the redox reaction. And finally, we should balance the hydrogen and oxygen atoms. Okay. So at least you should spend 5 minutes to memorize all these 5 steps. Okay. And then you should move into the examples. If you are following these, then I am damn sure that you can master this important topic. Okay. Now let us start balancing the first equation. So this is the example. Here, while writing the equation, you should leave some space in between because it shouldn't be congested. Because if you will be calculating the oxidation number of each and every atom present in the reactant side as well as the product side, right? And you will be writing those oxidation numbers at the top of every element. So there should be space to write all the numbers. So it shouldn't be confusing, okay, or it shouldn't be congested. So leave some space while writing the equation. That's the first thing. So before going into the step, first we should write down we should find out the oxidation number of all the atoms present in this equation. Okay. So that means that will be helping us to find out which atom is undergoing oxidation and which atom is undergoing reduction. Okay. So now let us start with FeSO4, right? See here in FeSO4 we have 4 oxygen. Now let us start with FeSO4. How many oxygen atoms are there? 4 oxygen. What is the oxidation number of one single oxygen? It is -2. If it is -2, since we are having, it is -2 for one oxygen, is it not -2? Since we are having 4 oxygens here, the oxidation number will be -2 into 4, that is -8. Okay. Now, if oxygen is -8, just listen carefully. If oxygen is -8, how will you find out the other atoms, oxidation number for other atoms? Say this molecule is a neutral molecule. If so, if oxygen is -8, based on this, we should give the values for the rest. Okay. So based on that, the rest of the other atoms should have +8. Okay. All these should have +8. Okay. Okay. So now we all know that sulfur is having the oxidation number +6. If it is +6, then iron Fe would be plus 2. So that the total will be plus 8. Understood? Okay. Now let us move on to the next compound KMnO4. How many oxygen atoms are there? 4 oxygen atoms. What is the oxidation number of one oxygen? It is minus 2. Okay. Since it is 4 oxygen, then it will be having minus 8. Okay. Now let us consider if this oxygen is having minus 8, the rest of the atoms should be having plus 8. Rest should have plus 8. Is it not? It should have plus 8 since it is a neutral molecule. Since it is a neutral molecule, if oxygen is having minus 8, the rest of the atoms should have plus 8. Okay. So now already from the rules of oxidation number, in my previous session I have explained how to calculate the oxidation number of individual elements. Say in that I have given some rules. Among the rules we have one rule for alkali metals. This potassium is an alkali metal. For all the alkali metals, that is 1A group, the oxidation number will be constant, that is plus 1. Okay, it is plus 1. So if K is having plus 1, remaining will be plus 7. If so, then manganese will be having plus 7. Okay, it will be having plus 7 since it is a neutral molecule. Okay, so oxygen minus 8, so the remaining will be plus 8. If K is plus 1, since it is an alkali metal, then the remaining will be given to manganese, that is plus 7. Understood? Now move on to the next one, that is sulfuric acid. How many oxygens are there? There are 4 oxygen. Since the oxidation number of oxygen is plus minus 2, 4 oxygen atoms, so minus 8. Okay. Now, since oxygen is having minus 8, the rest of the atoms will be having plus 8. Is it not? Plus 8. If so, hydrogen, we all know that oxidation number of hydrogen from the rules of oxidation or calculation of oxidation number, the oxidation number of hydrogen is plus 1. Since 2 hydrogen atoms are there, so plus 2. Okay, it is plus 2. Now, since here plus 2, here we have totally plus 8, then the remaining plus 6 will be given to sulfur. Okay, see here now itself I am finding little difficult to write the value. So that's why I told you in the beginning you should write the equation by giving space. Okay. Now we have found out the oxidation number of different elements that are present in different compounds present in the reactant side. So we shall move on to the product side now. See, when you move to the next side, that is product side, we have products in brackets. Is it not? So we should work out smartly now. For Fe2SO4 thrice, we have sulfate. For sulfate, we should take this as SO4. Okay, for sulfate, the oxidation number is minus 2. Okay, minus 2. How many sulfates are there? 3 sulfates. So what could be the oxidation number? Minus 2 into 3, minus 6. Okay, so minus 6. So minus 6, if it is minus 6, then here this Fe2 would be having plus 6. If it is a plus 6, here we are having 2 iron. Is it not 2 Fe? So what could be the oxidation number of this Fe here? Then it will be plus 3. 1 Fe is plus 3. Okay, 1 Fe is plus 3. Understood? Now we shall move on to MnSO4. What is MnSO4? See how many oxygens are there? 4. What is the oxidation number of oxygen? It is minus 2. Since we have 4 oxygen atoms, it is minus 8. Okay, since oxygen is having minus 8, the rest of the atoms will be having plus 8. Okay, the rest will be having plus 8. See, for yes, it is plus 6. Okay, for yes, it is plus 6. So the remaining manganese, it is plus 2. Understood? Now let us move on to the next one, that is potassium sulfate, K2SO4. See here, oxygen, 4 oxygens are there. Already oxidation number of oxygen is minus 2. So minus 2 into 4, minus 8. So the rest should be plus 8. Okay. Potassium, see this potassium, it's an alkali metal. So plus 1, 2 K are there. So plus 1 into 2 plus 2. If it is plus 2, then sulfur would be plus 6. Okay. Now check the next one, oxygen. How many oxygen atoms? 1 oxygen atom. Oxidation is number is minus 2. So here it should be having plus 2, but hydrogen oxidation number is plus 1. The original oxidation number is plus 1. Understood? Finally, we have found out the oxidation number of all the atoms that are present in the equation, both on the reactant side and the product side. Now we shall move into the topic, that is, we are going to solve this equation or balance this equation based on the rules given. Okay. What is the first rule? Should identify the atoms undergoing oxidation and reduction. Is it not? Among these atoms, we should identify which atom is undergoing oxidation and reduction. Okay. So first compound FeSO4. Okay. Here check the product side, Fe2SO4 thrice. Okay. See here first element Fe. Here the oxidation number is +2. Is it not at the top? But here it is +3. Mean the oxidation number has raised, is it not? Check the oxidation number of Fe. Oxidation number has raised. That is, it has raised by 1 unit. Is it not? One number has raised. Did you see? From +2 to +3. So one number has raised. What had happened here? Oxidation has taken place. Is it not? Since oxidation number is raised, since oxidation number has raised, oxidation reaction has taken place. Understood? Okay. Now check the next one. Potassium. See here potassium +1. Is it not? Here potassium +1. Here also potassium given +2, but here we have 2K. Is it not? So the oxidation number of K here is also +1. So there's no change here. But check Mn. You check Mn. What is Mn? +7. But here +2. Is it not? +7 +2. So there's a change by 5. Reduction has taken place. Is it not? Oxidation number has reduced from +7 to +2. Is it not? So oxidation number has reduced from +7 to +2. Oxidation number has reduced by 5. Is it not? By 5. If so, reduction has taken place. Reduction has taken place. Understood? Reduction. So now we have found out which atom has undergone oxidation and which atom has undergone reduction. So all the other atoms are the same. Only iron and manganese has changed. So they are those are the two atoms which have undergone oxidation and reduction. Now we shall move on to the second step, right? So let me rewrite this equation now. What is the second step? We should balance the atoms which are undergoing oxidation and reduction. Okay. So for that I am going to write this equation again. Okay. So let us move on to the step 2. This is step 2. In step 2, what happens here, that we should balance those atoms which have undergone oxidation and reduction. The atoms which have undergone oxidation is iron, and which has undergone reduction is Mn. So we are going to balance those two atoms. Okay. See, check here. I check iron here. Here we have 1, whereas here we have 2. So if you want to balance these two, we should put 2 here. Okay. So I am putting 2 here. So this iron is balanced now. Next I am checking Mn. See, Mn here we are having 1, and here also we are having 1. So this 2 on both the sides Mn is balanced. Okay. So step 2 is over, right? Step 2 is over. So now we are moving to step 3. What happens in step 3? We should balance the charge by cross multiplication. So for that I am going to write this equation again. Actually during oxidation, only 1 has increased. Okay, here Fe2 plus, whereas here Fe3 plus, only 1. Whereas during a reduction, there is change in 5. Okay, so what we are going to do is to balance the charge, just we are going to cross multiply. We are going to multiply this iron with 5 and this Mn with 1. Okay, so we are just going to cross multiply. So when you are multiplying this iron on both sides with 5, this equation becomes, see, when you are multiplying with this here, it becomes 10. Is it not? 2 into 5, 10. Whereas here already we are having 2. Okay, so we are going to put 5 here. So let us put 5. Okay, so now check how it is. 10 Fe, 10 Fe. Is it not? and then now we are going to multiply this Mn with 1 and this Mn with 1. Okay, so it will be the same. When you are multiplying this, it will be the same. So we have finished this step 3. So we have balanced by cross multiplying. Okay, now step 4. For writing step 4, what happens in step 4? Balance all the other atoms. We should balance all the other atoms except oxygen and hydrogen. Okay, we should balance all the other atoms except this oxygen and hydrogen. So for that I'm going to write another. So I'm going to rewrite this equation. Okay, step 4. So I'm going to balance this so I'm going to balance other atoms except hydrogen and oxygen. Okay, so first for that let me check potassium first. Here we have 1K, whereas here we have 2K. Is it not? So I'm going to put 2 here to balance potassium. So now potassium is balanced. Next I'm going to check manganese. How many manganese is here? 2 Mn. Is it not? But here only 1 Mn. So let me put 2 here again. Right? So let me put 2 here. Now this Mn is also balanced. Mn is also balanced. Okay. So iron is balanced. Potassium is balanced. Mn is balanced. Next we are going to check sulfur. How many sulfurs are here? 10. Is it not? And then here 1. So totally on the reactant side we have sulfur 11. Is it not? Sulfur 11. And now check the product side. How many sulfurs? Already 5 into 3. So 5, 15. Here 15, we have 15 sulfur here in this, and here we have 2 sulfur, and here we have 1 sulfur. So totally sulfur we have 18. So we are supposed to balance this 18. 18 over here we are having only 11. So here we are having 10. So instead of putting 1 here, you can have 8. If you are putting 8 here, this side sulfur will become 18. Okay. So let me put 8. When you are putting 8 here, automatically 10 sulfur, 8 sulfur. So totally this sulfur will become 18. Okay. So now it is balanced on both the sides. Here also sulfur 18, here also sulfur 18. So we have balanced everything. Let me write the equation again. Here I am putting 10, 2, 8, 5, 2. Okay. So we are going to so we are going to balance oxygen and hydrogen now. Now check how many hydrogens are there. Here we have 16. Is it not? Whereas here only 2. So if you want to balance this, we can put 8 here. Okay. So hydrogen again 16. So how many hydrogens are here? 16 hydrogen. Here also 16 hydrogen. Balance. Now check oxygen. How many oxygens are there? 10 into 4, 40. Is it not? So oxygen is equal to 40 here. Here 8. And here how many? 32. Is it not? So altogether we are having oxygen 80. Is it not? Now check here. How many oxygens? 4 into 3, 12. 12 into 5, it is 60. So oxygen here we have 60. Here 8. Is it not? Here 4 and here 8. So altogether oxygen is equal to 80. Is it not? So it is balanced. Oxygen is also balanced on both the sides. So this is step 5. So this is step 5. So we have come to the conclusion. See, all the elements, all the atoms are balanced here. Iron 10, iron 10. Sulfur, how many sulfurs are there? Sulfur 18. Okay, here 10 plus here 8. So 18. Here also we are having 18. Potassium 2, potassium 2. Manganese 2, manganese 2. Okay, oxygen 80, hydrogen 60. So finally we have balanced the redox reaction based on oxidation number. Okay. Well, fine students, I hope you might have understood what I have taught today. Let me meet you with another important topic in my next session. Until then, it's Dr. Anita Raj, your chemistry mentor signing off from me. Thanks for watching.